Question number 4. The equation of a circle is given by x squared plus 4x plus y squared minus 5 is equal to 0. Find the radius and the center of the circle. 2 marks. Solution. So I'll have here, let me rewrite the equation, the equation for x plus y squared minus 5 to be equal to 0. So if I look at this equation, the first terms have the coefficient to be equal to 1, so there's nothing to divide there. And then the arrangement is also set up that the binomial that was expanded in terms of x have its first and the second term following each other like that. So we just capture it there, that x squared plus 4x. Then what are we supposed to add? We are going to add here 4 times a half squared. And then when you come to the ones having the expanded form that had y squared, you will see that y squared does not have its second term. So that means its solution will simply be y minus 0 squared. If you have the first term of the expanded binomial and you cannot see the second term, it means the solution will be y minus 0. You can confirm this by saying here that if you have y minus 0 and then you multiply it by itself, you're going to have y into y minus 0 and then minus 0 into y minus 0. So therefore this will be y squared, and then y times 0 is 0, 0 here and 0, so these ones will mean nothing, so you end up with y squared. And that's why when you fail to have the second term, when you're considering the first term here, you end up writing it as y minus 0 squared and you're done. So this should be equal to, you take this negative 5 to the other side of the equal sign, it will simply be 5. And then what have you added on the left side? We've only added this one, that is what you add on the right side. So plus 4 over 2 squared. So we end up solving here. We are going to have x plus 4 divided by 2, that is 2. So x plus 2 squared, I've ignored that. And then it will meet plus y minus 0 squared to be equal to, here I'm having 4 plus 4 divided by 2, which is 2 squared, that is 9, and 9 can be written as 3 squared. And therefore now we can do the comparison. X minus a squared plus y minus b squared is equal to r squared. So we simply know that the value of r is equal to 3, and the value of the center we're going to have here minus a is equal to 2, and then you're going to divide both sides by the negative sign so that you are left with a. It will be equal to negative 2, and then here we have minus b is equal to minus 0, so therefore b is equal to 0. So the coordinates of the center will be negative 2, 0. Question 5. Determine the center and the radius of the circle represented by the equation 2x squared plus 2y squared minus 32 to be equal to 0. 3 marks. Solution. Let me rewrite this equation here. This is 2x squared plus 2y squared minus 32 to be equal to 0. Now if you look at these two terms, these are first terms of the expanded binomials as far as the equation of a circle is concerned, and since they are having a coefficient of 2, it means we will have to divide both of these terms by 2 to ensure that their coefficients will be equal to 1. So we end up having x squared plus y squared minus 16 to be equal to 0. And then we said previously that when you have the first term and the second term you cannot find it, the only thing you can do here is to consider the fact that this will be written as x minus 0 squared as a binomial, and the other one here can also be written as y minus 0 squared, and this will be equal to 16. This negative 16, we take it to the right side of the equal sign, you're going to have positive 16. And therefore, x minus 0 squared plus y minus 0 squared, this should be equal to 4 squared. So that means, as far as the center is concerned, we are going to say here that we compare with the equation of a circle, x minus a squared plus y minus b squared to be equal to r squared. I'm sorry, this one was supposed to be squared here. So therefore, by comparison, we'll be in a position to say that a will be equal to 0 and also b will be equal to 0 for our center, and the radius will be equal to 4. So I can have here the coordinates. A will be 0, 0. That means the center of that circle is at the origin where the Cartesian plane is concerned, and the radius here is equal to 4. And this is the solution. Question 6. The diagram below shows a sketch of a circle within the Cartesian plane such that it cuts the x-axis at negative 1.5 and 6.5 and the y-axis at negative 2.5 and 5.5. Part A. State the coordinates of the center of the circle, 1 mark. And then part B. State the radius of the circle in surd form, 1 mark. Part C. Find the equation of the circle in the form ax squared plus ay squared plus bx plus cy plus d to be equal to 0, where a, b, c, and d are integers, 2 marks. So to find the solution for the first part, where we are being told to state the coordinates of the center, we need to consider the locus of a point equidistant from the x-intercepts here, and also we consider the locus of a point equidistant from the y-intercepts, and then where the two lines meet, that is where we'll get our center from. So how do we get that? We are going to solve for part A by considering the midpoints. So the midpoint in relation to x, we are going to consider the formula where we talk of x1 plus x2 divided by 2, and then in terms of y we are going to have y1 plus y2, 5.5 here, divided by 2. So this is 1. So here we are going to have minus 1.5 plus 6.5, that is simply 5 divided by 2, that is 2.5, and here negative 2.5 plus 5.5, that will be equal to 3, and 3 divided by 2, that will be equal to 1.5. Therefore, the locus of this point, as far as x is concerned, will be the line where x is 2.5. So that line will be there, which is parallel to the y-axis. And then the locus of a point equidistant from the y-intercepts will be 1.5. So that one will be a line where y is 1.5, and at the same time it is parallel to the x-axis. And this is where we come up with our center. So the center here is 2.5 and 1.5. So these are the coordinates of the center. So we've answered the first part. So the second part here, part B, we are being asked to find the radius of the circle. Now for us to find the radius of the circle, we need to consider a right-angled triangle where the radius of that circle is the hypotenuse of that right-angled triangle. So this is my right-angled triangle here. So all I need is to know its base and the height. So since this is the line where y is equal to 0, the x-axis, from negative 2.5 to 0, that is 2.5, and then plus 1.5 here, you're going to get 4. So that means the height of this triangle is 4, and then the base of this triangle will be, this is where the line x is equal to 0 to the line x is equal to 2.5. So it means the base here will be 2.5. And therefore, the radius will be equal to the square root of 2.5 squared plus 4 squared. So when you consider that, you're going to find that the square root of this number will be, the radius of this circle will be 22.25, and that will be the solution for the second part. And then when you consider now part C, we've got the coordinates of the center and we've got the radius. Now we can simply find the equation of a circle. So we can first of all write the equation of a circle in its basic form here, plus y minus b squared to be equal to r squared. And then we substitute with the values that we have. So we will have here x minus 2.5 squared, I've substituted for a, and then b will be this one here, plus y minus 1.5 squared. This should be equal to the radius squared, which will simply be 22.25. And then we expand the binomials. We are going to have x into x minus 2.5, and then minus 2.5 into x minus 2.5, and then in relation to y, you're going to have plus y into y minus 1.5, minus 1.5 into, minus 1.5 into y minus 1.5. This will be equal to 22.25. And then we open the brackets. You're going to have here x squared minus 2.5x minus 2.5x plus 6.25, and then plus y squared minus 1.5y minus 1.5y plus 2.25. This should be equal to 22.25. And then we put like terms together. We're going to have x squared minus 5x plus 6.25, and then plus y squared minus 3y plus 2.25. This should be equal to 22.25. And then we can add the whole numbers here. We end up having x squared, and then I can also consider this form here. It will be x squared plus y squared, and then the term having x minus 5x, which is here, and then the term having y minus 3y, and then when you add these two numbers, you're going to get plus 8.50. This should be equal to 22.25. And then the last step is to combine these whole numbers. So I'll have x squared plus y squared minus 5x minus 3y. When I take negative 22.25 to the other side of the equal sign, it will become negative. So I'll have 8.50 minus 22.25. You end up with negative 13.75, and this will be equal to 0. So this is the solution. Question 7. Line PQ is the diameter of a circle such that the coordinates of P and Q are -2, 2, and 2, -6 respectively. Find the equation of the circle in the form ax squared plus ay squared plus bx plus cy plus d to be equal to 0 for marks. To answer this question, I can consider this diagram of a circle here. So I know that the points at the circumference where the diameter is concerned, there is P, which is -2, 2. I can have it there. And then Q, which is 2, -6. I can have it on the other side. So I'll be in a position to say here that since I'm looking for the coordinates of the center, this will simply be the midpoint between these 2 points. And how do you find the midpoint? So we can have here that the center will be equal to the midpoint. And to find the midpoint, you're going to consider x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. For this case, x1 will be equal to -2, and then plus 2 divided by 2, and then y1 will be equal to 2 plus -6 divided by 2. So we end up getting the midpoint to be 0 and -2. And this represents the coordinates of the center. So I can have it here as 0, -2. And then, in order for us to come up with the equation of a circle, we need to first of all know the radius. So the reason as to I've captured this diameter here as a diagonal is so that I can be in a position to draw the right angle triangle that will make my work easier. So when I use this right angle triangle here, I know that the equation of a circle is simply the Pythagoras relationship. So I need to know the distance here and also the distance in relation to x. So to find the distance, the height of this triangle here, the height will simply be equal to -6 to subtract, it will be the distance from -6 to -2, which is simply 4. And then in relation to the x-axis, it will be the distance between 2 and 0, which will be 2. And therefore, to get the radius here, we will say that the radius will be equal to the square root of 4 squared plus 2 squared. And therefore, the radius will be equal to the square root of 20. Now, the equation was asking us to find the question was asking us to find the equation of a circle. So how are we going to get the equation of a circle? We just write the equation of a circle here, that x minus a squared plus y minus b squared to be equal to r squared. And then we substitute the coordinates of the center for the values of a and b. So you're going to have x minus 0 squared plus y minus negative 2 squared. This should be equal to, radius squared will simply be 20. Now for this binomial here, its solution will simply be x squared, and then for this other binomial here, this will be equal to y plus 2 squared to be equal to 20. Now we can expand this second binomial so that we have y into y plus 2 and then plus 2 into y plus 2 to be equal to 20, and here I'll have the addition of x squared. So we end up having x squared plus y squared plus 2y, which is the multiplication of this one, and then plus 2y plus 4 to be equal to 20. And then we put like terms together, we end up having x squared plus y squared plus 4y. And then since you've been told here to have 0 on the right side of the equal sign, I'll take positive 20 to the other side of the equal sign to meet positive 4. So I'll have positive 4 to subtract 20. I'll end up with negative 16 to be equal to 0. And this is the equation of the circle. Question 8. The circle given by the equation x squared plus y squared plus 2x minus 8y plus p is equal to 0 passes through the point 2, 4. Determine the value of p, hence find the equation of the tangent to the circle at the point negative 1, 1 for max. Solution. So let me write the equation here, x squared plus y squared plus 2x minus 8y plus p to be equal to 0. So to get the value of p, we need to substitute in the equation with x and y, since the circle will pass through this point. So I'm going to have here as the value of x, I'll have 2 squared plus the value of y, which is 4 squared, plus 2 multiplied by 2, and then minus 8 multiplied by 4, and then plus p to be equal to 0. So here we'll have 4 plus 16 plus 4, and then subtract 32 plus p to be equal to 0. Then here we'll have 16 plus 8. This will lead us to 24, and then 24 you subtract 32, you end up with negative 8. So negative 8, sorry, this one here is 0. So negative 8 plus p will be equal to 0. And therefore when you take negative 8 to the other side of the equal sign, you end up having the value of p to be equal to 8. And that's the solution there. And then to find the equation of the tangent here, we need to first of all know the coordinates of the center and also the radius. So to find the center, we need to first of all rewrite the equation here. This will be x squared plus y squared plus 2x minus 8y, and then to be equal to negative 8. I am putting the value of this whole number to the right side of the equal sign as I consider completing the square method here. So then these two are the first terms of two expanded binomials. So since the coefficients is equal to 1, we are not going to divide by anything. So straight away I'll combine the first term and the second term of a binomial in relation to x, and whatever I'm going to add here will be 2 times a half squared, and then in relation to y I'll have plus y minus 8y, and then plus negative 8 times a half squared. This should be equal to negative 8 plus 2 times a half squared, and then plus negative 8 times a half squared. And therefore, on simplification here, as I combine the squared terms, I'll end up having x plus 1 squared, and then plus y minus 4 squared, since here it will be negative 8 divided by 2, which is negative 4, and this should be equal to negative 8 plus, this one will be equal to 1, and then plus, this will lead us to negative 4 squared, which is 16. So negative 8 plus 1, that is negative 7 plus 16, you end up with 9, which can simply be written as 3 squared. So 3 squared will meet these other parts of the equation. You're going to have x plus 1 squared plus y minus 4 squared. So we can compare now with the equation of a circle, that x minus a squared plus y minus b squared to be equal to r squared. And therefore, negative a is equal to 1, and therefore a is equal to negative 1, since you're going to divide both sides by the negative. And then negative b will be equal to negative 4. The negatives will cancel out, and then you are left with b to be equal to 4. And therefore the coordinates of the center is negative 1, 4, and the radius here is equal to 3. Now, we need to have this information on the diagram so that we can be in a position to see how that equation of the tangent will look like, and then we will be in a position to state the line that forms the tangent. So I've captured this diagram here, and the reason as to why we found our center here is to be in a position to know how that center relates with this point. And from the look, you can be in a position to see that the center and the point that you are given here, they are all on the line x is equal to negative 1. And since they're all on this line, it means an equation of a tangent at this point here will be this line here, and according to this point, this is the line where y is equal to 1. So the equation of the tangent is the line where y is equal to 1. Always remember that the tangent to a circle at a point is perpendicular to the radius of the circle at the same point. Let's consider some KCSE questions. Number 9. The points with coordinates 5, 5 and negative 3, negative 1 are the ends of a diameter of a circle center A. Determine the coordinates of A, 1 mark, and then part B, the equation of the circle, expressing it in the form x squared plus y squared plus ax plus by plus c to be equal to 0, where a, b and c are constants, 3 marks. Solution for part A, we are considering the coordinates of the center. So I've captured the diagram here of a circle, and I want us to look at these 2 points. I can have the point here as negative 3, negative 1, and this other end to be 5, 5. The reason as to why I'm capturing the diameter as a diagonal here is for us to be in a position to come up with the right angle triangle easily, so that we can also come up with the radius. So how do we get the center? So the center will simply be the midpoint of these 2 endpoints of the diameter. So the midpoint, you are going to take x1, which is negative 3, and then plus x2, which is 5, divided by 2. And then in relation to y, we are going to take y1, which is negative 1, plus y2, which is 5, and then divide it by 2. You end up getting a to be equal to, that means the coordinates of a will be 1, 2, because minus 3 plus 5 is 2, and 2 divided by 2 is 1. And then minus 1 plus 5 is 4. 4 divided by 2 is 2. So these are the coordinates of the center I can have here in my diagram as 1, 2. And then, so this is the solution for part A. For part B, we've been told to find the equation of the circle expressing it in this form. So then, before we solve for part B, we need first of all to know the radius. And for us to be in a position to know the radius, we need to capture a right angle triangle here, where the hypotenuse is the radius of that circle. So then I'll need to know the distance in relation to height and the distance in relation to length. The distance in relation to height will be the difference between y2 minus y1. So I'm going to have here 5 minus 2, which is 3. And then the difference in terms of x will be x2 minus x1, which is 5 minus 1, which is simply 4. So then now we can find the value of r. We'll be in a position to say here that r will be equal to the square root of 4 squared plus 3 squared. That means the base and the height to get the hypotenuse. So we end up getting the value of r to be equal to, this is 16 plus 9, which is 25, and the square root of 25 is simply 5. So then we can now use the equation of a circle here. We can write the equation of a circle again. We can have here x minus a squared plus y minus b squared to be equal to r squared. Let's substitute with 1 and 2 for the values of a and b. You're going to have here x minus 1 squared plus y minus 2 squared. This should be equal to 5 squared. Now all we need to do is to expand this equation here so that we get it to this form. So I can begin by expanding the first binomial here. I'll have x into x minus 1, and then minus 1 into x minus 1. And then in relation to y, I'll have plus y into y minus 2, and then minus 2 into y minus 2. This should be equal to 25. And then now I can open the brackets. I'll have here x squared minus x minus x plus 1. And then in relation to y, I'll have here y squared minus 2y minus 2y plus 4 to be equal to 25. And then now I put like terms together. I've got these two like terms and these other two here. So I'll end up having x squared minus x, that will be minus 2x plus 1, and then plus y squared minus 2, that will be minus 4y plus 4 to be equal to 25. And then straight away I can consider the last step, where I write the equation in this form. I'll have x squared plus y squared, and then here I have minus 2x in relation to the term having x, and then the term having y will be minus 4y, and then all the whole numbers will fit here so that I'll have to be equal to 0. So I'll have plus 1 plus 4, that is 5, and then you subtract 25, which I'll take it to this other side. So 5 minus 25 will be equal to minus 20 to be equal to 0. And this is the solution to the question. Question 10. A circle whose equation is x minus 1 squared plus y minus k squared is equal to 10 passes through the point 2, 5. Find the coordinates of the two possible centers of the circle. 3 marks. Solution. So let me rewrite the equation here. X minus 1 squared plus y minus k squared to be equal to 10. So I'm going to substitute with the values of x being represented here, since this is a point where this on the circumference of that circle. So then I'll have 2 minus 1 squared. I've substituted x with 2, and then plus y, which is 5. I'll have here 5 minus k squared. This will be equal to 10. Inside this bracket, I'll have 2 minus 1, which is 1, and then 1 squared will simply be 1. And then on this other side, I'll have to expand. So 5 minus k to be multiplied by 5 minus k, this should be equal to 10. So in relation to 5 minus k, I'll have 5 into 5 minus k, and then minus k into 5 minus k. This should be equal to 10, and then I'll have here plus 1. So I'll have 1 plus 25 as I open the brackets, minus 5k minus 5k, and then plus k squared to be equal to 10. And then I put like terms together here. I've got this one here, and then I can also add the whole numbers. I'll have 26 minus 10k plus k squared to be equal to 10. And straight away you can be in a position to see here that I'm dealing with a quadratic equation. So I can start by considering the first term here. I'll have k squared minus 10k, and then I'll bring 10 to the other side of the equal sign, so I'll have 26 to subtract 10, I'll have positive 16. This should be equal to 0. And here is a quadratic equation that we need to solve to get the value of k. So by solution here, we are going to consider the product and the sum. And we said that the product, you consider the coefficient of the first term times the third term here. So that is 1 times 16, which is simply 16. And the sum will be the coefficient of the second term here, which is negative 10. So we need to look for two numbers whose multiplication is 16. And then when you add the same numbers, we are going to get negative 10. So the two numbers will be 8 and 2. And then since the product is positive, it means they'll all be negative. So that will meet the condition that is here. So these are the two factors that you're going to use to split the second term into 2. So we end up having here that k squared minus 8k minus 2k plus 16 to be equal to 0. And then you consider the first two terms. We factor out what is common there. You can factor out 8k, and then you are left with here k minus 8. And then I need to ensure that I have k minus 8 inside this bracket. So the number that will be outside here will definitely be negative 2 to be equal to 0. Therefore, the first factor we consider what is outside the bracket, which is k minus 2, and then one of the brackets k minus 8 to be equal to 0. And therefore it means that k minus 2 will be equal to 0, and also k minus 8 will be equal to 0. And then when we make k the subject here, k will be equal to 2, since I'm taking this negative number to the other side of the equal sign, and here k will be equal to 8. And therefore, since the coordinates of the center are AB, and B is the one that is being represented by 2 and 8, that means whatever we've solved, which is k, the two coordinates of the center can be, the coordinates of A is -1, A is -1 here, so it can be -1 when B is 2, or it can be -1 when B is 8. And these are the two possible centers of that circle. Question 11. The circle shown below cuts the x-axis at -2, 0 and 4, 0. It also cuts the y-axis at 2, 0 and 0, -4. Determine the Roman 1 of part A, coordinates of the center, 1 mark, and then Roman 2, the radius of the circle, 1 mark. And then part B, the equation of the circle in the form x squared plus y squared plus ax plus by is equal to c, where a, b, and c are constants, 2 marks. We are looking for the coordinates of the center in this diagram here. We need to first of all know the midpoint, and this is to help us to get the locus of a point equidistant from the x-intercepts, and then we need to find also the locus in relation to a point equidistant from the y-intercepts. So for part A, Roman 1, we need to first of all consider the midpoint. We need to first of all consider the midpoint here, and this midpoint will be equal to, we consider the values of x. I'll have -2 plus 4 divided by 2, that is in relation to x, and then for y I'll have 2 plus -4 divided by 2. So I end up getting here, this will be 1, so -2 plus 4, that is 2 divided by 2, that is 1, and then 2 minus 4, that is -2 divided by 2, that will also be -1 there. And this leads us to the solution for the coordinates of the center. And if you want to see them clearly in the diagram, if you want to see that coordinate clearly, you will see that x, in relation to x, we are going to have 1, and this is where the origin is, so 1 will be on this other side. So this is the locus of a line equidistant from the two coordinates or the two intercepts. And then in relation to x, we are told here, in relation to y, there is -1, so -1 will be somewhere below the x-axis, so -1 will be somewhere there. So our center of a circle will be there as 1, -1. And then the second question is asking us to find the radius. So Roman 2, we are going to find the radius. And to find the radius, we need to come up with a right angle triangle where the radius is the hypotenuse of that triangle. So I can pick my right angle triangle at this point. This is the right angle triangle here. So in relation to the distance here, I'm going to consider that y at this point is, this is -1 to -4. We've got 3 steps, and then in relation to x, this is 0 and this is 1, so the base here will be 1. So to find the radius, you're going to say here that a radius will be equal to 3 squared plus 1 squared, and then you find its square root. So this will be equal to the square root of 10, which is simply 3.162. 3.162. And then for part B of the question, so part B of the question, we are being told to determine the equation of the circle in the form that has been given there. So I can write the equation here: x minus a squared plus y minus b squared to be equal to r squared. Now that I know the coordinates of the center, I can simply substitute. I'll talk of x minus 1 squared plus y minus, this minus is in the formula here, and then there is minus 1 to be equal to r squared, which is simply 10. So we can expand this equation. The binomial having x will have x into x minus 1, and then minus 1 into x minus 1. And then the binomial having 1, this one here will be positive, so you're going to have plus y into y plus 1, and then plus 1 into y plus 1. This should be equal to 10. So by simplification, we end up having x squared minus 1x minus 1x, and then plus x, and then in relation to y, we're going to have plus y squared plus y plus y plus 1, and this should be equal to 10. And then now we can simplify as we consider this form. I can begin by talking of, or maybe let us put like terms together. There's this like terms here, and then we've got this other set of like terms. So we're going to have x squared minus 2x, and then plus 1, and then plus y squared plus 2y plus 1. This should be equal to 10. Now let's consider this arrangement here. So we'll have x squared plus y squared, and then the term having x minus 2x, and then the term having y will be plus 2y, and then I combine the whole numbers together here. I'll have 1 plus 1, that is 2, and then I take 10 to the other side of the equal sign. I'll have 2 minus 8, or else, since you're told to have the whole number on the right side of the equal sign, I'll have this one here to be equal to 10, and then I take 2 to the other side of the equal sign, which will simply be 10 minus 2. So the final answer will be x squared plus y squared minus 2x plus 2y to be equal to 8. And that's the solution. The last question, number 12. The equation of a circle is x squared plus y squared minus 4x plus 6y plus 4 to be equal to 0. On the grid provided, draw the circle. So I can begin by rewriting the equation here. Minus 4x plus 6y plus 4 to be equal to 0. Looking at this equation, the coefficients of the first term be equal to 1, so there is nothing to divide here. So all I can do is to consider the first term and the second term of the expanded binomial in terms of x, and then what I will add here will be negative 4 times a half squared, and then in relation to y, I'll have y squared plus 6y, and then I'm going to add 6 over 2 squared, and this should be equal to, I take this whole number to the other side of the equal sign, negative 4, and then I add everything that I've added on the left side of the equal sign. So I'll add negative 4 divided by 2, negative 4 divided by 2 squared, plus 6 divided by 2 squared. And then by simplification, I'll have x minus 4 divided by 2, which is 2 squared, plus y, and then I'll have 6 divided by 2, that is 3. I'll have here plus 3 squared, and this should be equal to negative 4 plus, this is negative 4 divided by 2 is negative 2, and negative 2 squared, that is 4. And then here I'll have plus 6 divided by 2, which is 3, 3 squared, that is 9. So therefore, I'll end up having here x minus 2 squared plus y plus 3 squared. This should be equal to minus 4 plus 4, that is 0, then 0 plus 9, that will be 9, which can be written as 3 squared. And then the next step is to consider comparison. So x minus a squared plus y minus b squared, this should be equal to r squared. And for this case, we will say that minus a is equal to minus 2. The negatives will cancel, therefore a is equal to 2. And then minus b is equal to 3. Then we divide both sides by the negative, we end up with b to be equal to negative 3. And therefore the coordinates of the center will be 2, negative 3, and the radius will be equal to 3. So you end up with a diagram of the Cartesian plane that looks like this. So the most important thing you need to capture here is the center, which is 2, negative 3, mine is here, and you need to ensure that the radius is equal to 3, and then you draw that circle. So this is how you solve questions in relation to the equation of a circle.